Ribosomes are proteins involved in the translation of mRNA into amino acids. There is a specific type of ribosome that resides in your mitochondria, and its role is to translate mitochondrial mRNA encoded by the mitochondrial DNA. Similar to the cytoplasmic ribosome, the mitochondrial ribosome has both a large and a small subunit. A major difference between the two, however, is that the mitochondrial ribosome has a much greater protein to RNA ratio than cytoplasmic ribosomes. The mitoribosome translates 13 proteins that are encoded in the mitochondrial DNA. These proteins play a role in both the structure and the function of the mitoribosome and constitute many of the differences found between the cytoplasmic ribosome and the mitochondrial ribosome. For example, there are proteins in the mitochondrial ribosome responsible for the specificity of GTPase, and they also play a role in the mRNA channels.
Mitoribosomes are composed of a large subunit and a small subunit made up primarily of protein rather than RNA. Single-particle cryo-EM image reconstruction revealed a porous overall structure composed of MRPs and fewer rRNA-exposed regions. Mitoribosomal RNA is also truncated and lacks many important features that typically allow for the initiation of translation. Higher resolution studies revealed extensions on homologous and mitochondrial-specific MRPs that allow for inter-MRP interaction and creation of a new binding surface. Mitoribosomes also possess a polypeptide exit tunnel and a polypeptide accessible site. These serve as an exit pathway for translation and as a regulatory component with an unknown specific function. The studies also revealed the central protuberance component of the mitochondrial large subunit. It possesses tRNA and several structural mitochondrial-specific MRPs that contribute to the overall structure of mitoribosomes.
Hey guys, Anonymous Rhino here, gonna drop some knowledge. Problems with the mitochondrial ribosome or mitoribosome have shown symptoms that are similar to metabolic disorders caused by ATP synthase or pyruvate dehydrogenase complex deficiencies. There is a link between malfunctioning mitoribosomes to energy deficiency disorders. A mutation in the nuclear gene that encodes for mitoribosome directly causes decrease in the oxidative phosphorylation expression of the electron transport chain as part of ATP production. To explain this phenomena, consider the fact that the mitoribosome translates mito-mRNA that is transcripted from mito-DNA. The ETC complexes 1, 3, 4, and ATP synthase have subunits that are gene-encoded in the mitogenome, thus directly affected as a result of a mitoribosome mutation.